Okay, why? Sorry, repeat today?
No, I'm just kidding.
Yeah, we should start.
We should. Yes.
Yeah, I think we should.
Okay, yeah, I'll just finish 5.3 and then let's review. Not much left. Or
Why not? Everything should be
everything should be test, what?
every day is review for the test.
Oh yeah, yeah. I mean, nothing to say. Okay, review things. Okay, since you guys want so much. What is this? A is equal to P times P d P inverse. What is it?
Similarity.
Okay, similarity. So what does similarity tell you? One characteristic. Do they have something common? Same thing. They share the same thing. One thing. Okay. What is chapter name of this?
Eigenvalue?
Yes, yes. Eigenvalue. They do share the same eigenvalues. Okay. Okay. So, applied math or applied science. Why do we care? Like, I have matrix A. Why do I bother with constructing another 3 matrices and use this instead of the original matrix? It's not going to be an example. It's
Is
going
it less computations?
Yes, yes. Because let's say I want to multiply A 10 times, say 1,000 times, or whatever, many times. Then what you're gonna get at the end of the day is, what is it, guys? Let's say if I multiply A, let's say K times. I want to multiply A K times. Then P D P inverse. Then where should I write K?
After the B.
Yes. So you get this, you raise the power of D to K, and this is enough computation. And what is the advantageous of using D to the power to K? D to the power K. These, the reason we use these diagonal matrix. Right? So it's like this. So I want to raise this power, this D to the power 10. Then I end up getting 5 to the power 10, 3 to the power 10. Right? So if you have long matrix, the same. So you just raise the power to. If you have, say, D is some matrix that has many things, that has the non-zero number on the main diagonal. Okay. All zeros, all zero, all zero, all zero. Okay. I raise the power. Okay. You just raise the power. Make sense? So this is, okay, so it's not easy topic, but it's going to be helpful for your future. So let's say you know the given matrix that you're going to use is diagonal matrix. Okay, and then I want to raise the given matrix to the power k. Do I need to compute? You just get the value when you're writing coding, and when you write code or your code. So you get the value, you raise the power. It doesn't. I think the computation. You just need compute k times, I guess. K times, k times, k times, k times. It's gonna save a lot for this unnecessary part. Okay. Anyway, so that's the reason. Computational, to save computation cost, we use this similarity. So we learn this. Now, eigenmatrix, I ask you to find find D and P. What would that be? Now, let's learn the definition. Okay, can you read this to help me?
The diagonalization theorem, an n by n matrix A is diagonalizable if and only if A and n linearly independent eigenvectors. In fact, A equals P inverse with D a diagonal matrix if and only if the column of P and n are linearly independent eigenvectors of A. In this case, the diagonal entries of D are eigenvalues of A that correspond respectively to the eigenvectors in P.
Thank you. So you have matrix A. Let's say you try to find eigenvectors, and that will give you matrix D. Okay. So once you find the eigenvalue, you can find eigenvectors. Okay. First chapter, what did we do? First chapter. 5.1. What did we do? This Monday.
Eigenvectors.
Right. So I give you eigenvalue at the beginning, and then I ask you to find the eigenvectors, right? So you know how to find eigenvectors. Second chapter, I think yesterday. Yeah, it is. Tuesday or Wednesday or something. I asked you to find eigenvalues. Right? How do we find? How do we find eigenvalues? If I give you some matrix.
Subtracting A from the identity matrix times the
Lambda.
constant lambda.
And then find the determinant and set that equal to 0, right? To get lambda, right? So you know how to get this. So let's practice. So instead of finding the P and D for this 3 by 3, it's kind of confusing. So let's start with 2 by 2 that we already know. Okay. I mean, we already know for this example that we did. I gave you P and D at the beginning, so just forget about this for this one. Let's say I give you A. Now let's find eigenvalues. Find it. How do you do this? Any idea for those who don't know yet? Okay, first step. This is going to be example. Okay, I may give you 2 by 2 instead of 3 by 3. I just want to ask if you know how to find eigenvalue, and also I want to know if you know how to find eigenvectors, and I want to ask one more step. So here, find lambdas eigenvalues. Okay. 2, find corresponding eigenvectors. And then express by the general form of A to the power k. Okay, this 3 steps I'm gonna ask. For sure. Yes. Because we have different eigenvectors for different eigenvalues. Right? So first step, find eigenvalues. How to start?
You subtract lambda times the I2 identity matrix,
Uh-huh.
and then take the determinant of that.
Correct.
Set it to 0.
If you don't mind, please. Sure, accept it. Let's see. It's actually a review what we did this week. Okay, good. Perfect. Good, good. Great. Wow. That actually the answer, yes. 3 and 5, right? No. Here you go. The one did? What the one did is you subtract you get lambda times identity matrix. Then you get A minus lambda I, and that is 7 minus lambda 2 A4 1 minus. Now you multiply these two cross minus those two. Okay, so this one's a bit small for me too. To show 7 minus lambda 1 minus lambda minus 2 times negative 4. Then what you're gonna get is lambda squared minus 8 lambda plus 15 equal to 0, equal to 0. Okay. So the lambda is what?
7 minus.
Right? Yeah. Okay. So lambda is what? 3 and 5. Therefore, eigenvalues are 3 and 5. Right? That's it. So first one is checked. So I found out lambda is 3 and 5. Second, find the corresponding eigenvectors. Eigenvector, find it for lambda 3 and also for 5. Lambda 5. Right, guys? Don't know? Trouble. X equals to lambda x. So first, lambda is 3, ax equals to 3x. Find the x, find the vector x that makes this thing true. Right, guys? Good. Oh God. Okay, if you don't know this, let me know. I'm happy to help you. That's very good. Okay, so just forget about everything. Let's focus this thing. I have a almost the okay, so I want to wait until my idea. Yeah, okay. Ax is equal to 3x. Okay, I want to find x that makes this thing true. Okay, how do we do? Oh, a is right here. Ax minus 3x. I move 3x to the left. Okay, and then what?
We create the identity matrix with 3.
Mm-hmm. So we cannot do just like this. We cannot do this. It's wrong. Once you write this, I give you all like 0 point. There is not accepted. So if you write this, you don't deserve it. So we cannot do any addition or subtraction between a matrix and scalar constant. We cannot do this. That's why we have to write ax equal minus 3 times I x. So in elementary school, middle school, when you're learning multiplication for the first time, 3 is equal to 3 times 1. If you multiply some number by 1, you always get the same number. Right? Same thing, same logic here. You multiply some vector or matrix with identity matrix, you still get the same number or same vector. So I'm using the same logic here. So that's why you could write I between these two. Okay? And I want to factor out x. Minus 3I x. Okay? And then what? And then what, guys? A is so what do you do, guys? A is right here. So A minus 3I is what?
4, 2, negative 4, negative 2.
A minus 3I. 4, 2, negative 4, and negative 2. Is there anyone who doesn't understand this? Brian, do you understand this? If I subtract, if I do A minus 3I, I only subtract numbers from here. Okay? I leave, because identity matrix is only, the non-zero entries are on the main diagonal. So I'm just subtracting numbers from the main diagonal entries. Okay? Make sense? And then what? So I got this. What I want to do is next step is x that makes this thing zero. X that makes this thing zero. How do we do this? Yeah? Yes. 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 Back to chapter 1. Augmented matrix. Okay. Actually, I'm going to use this true false. Anyway, so how do this? augmented matrix, you write, copy paste this, and then what? Yes, yes.
Since we know lambda is in fact 3, are we looking for a consistent or non-trivial, or a trivial or non-trivial solution?
Okay, so back to the question. So what am I asking? Good question. So I want to find. I give you a matrix A. Right? I ask you to find P and D, meaning you have to construct a matrix D that contains eigenvalues, and I want to ask you to make the matrix P that is eigenvectors. Okay, we're trying to learn this. So the first step is finding eigenvalues. Okay, the next step is corresponding eigenvectors. Okay, what is the definition of eigenvectors? That gives the eigenvalues is. We'll go back to the. We're trying to find non-trivial solution. That's why we want to find a solution that is not all zero. Here. I think actually you read this a few days ago. So eigenspace or eigenvector. Eigenspace you can find eigenvector you can find eigenspace, right? So you want to find this. You want to find x that makes this thing true. That ends up being eigenspace. And then if it's zero, it's always zero. So we want to find non-trivial solution. So back to the question. Okay, so here we want to find non-trivial solution. How do we do? Row reduce? Okay, so obviously, can I make zeros? Right? All zeros. What about the first row? I can just
1, 1/2, 0.
So x is so from the result of row reduced augmented matrix, what can you find? What did you just find? X1 is what?
Negative 1/2 x2.
Then what? You can write solution x in terms of x2, right? So x2 is x is 1. Yes. X2 times -1/2, 1. Okay. So you repeat the same process with lambda is 5. Try. Yes.
Just a question on this.
Yes, yes.
So, where do you find, what is,
This eigen space.
that's your eigenspace?
Yes, yes. That's eigen space. So.
Right.
Because I think this is what we did. What did we say? I find an eigenspace this following the same way that we just did. You pick any vector, and then it will be eigenvector. Yes, Dylan.
So whenever we're solving for this, we should always find linear dependence because that eigenvector has to scale through the entirety of the eigenspace.
Can you repeat again, sorry?
So whenever we're like testing that like linear dependence, at 4, 2, 0, -4, -2, 0, we should always find some degree of dependence if it's an actual eigenvalue because that eigenvector
yes.
has to scale through that space.
Yes, 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 yes. So if you find, the okay, so Dylan, just correct me if I understand your question. So what you're saying, if I end up having independent, so you're talking about this independence?
Yeah, that ended up being like
Let's say, so independent meaning, we're gonna have p much in every row.
yeah,
So then it's gonna be,
so that wouldn't be an eigenvalue.
yes, yes, because we already have eigenvalue. But that is not going to have eigenvector, eigenspace. Yeah, it's quite possible that you have eigenvalue, but you don't have eigenvector in the case. Yeah, I think so. Because sometimes you have eigenvalue, but you have smaller space for eigenvectors. That's the next example we're going to see. Okay. Anyway, so did you guys get the answer?
x1 equals -1 and x2 is free.
No, x1 is -x2. X2 is free.
Yeah.
Okay, good. Very well. Okay, so let's see if you got some answer. Oh yes, I think it's right. So now how we construct. Next question is. A is P, D, P inverse. Now I want to find D first. D is just simply copy paste the eigenvalues we want. Let's say I want to write, we have eigenvalues 3 and 5, right? This 5, 3, that's it. So I just copy paste eigenvalues on the main diagonal. Okay? And then P should be the corresponding eigenvector. Okay, so for 5, -1, 1. And then 3, I think we found -2 and 1. -1/2 and 1. And this will be P.
So whichever number you have in the upper left column of D has to be the first column of P.
Yes. So I pick 5 for the first entry of diagonal matrix, right? Then the first vector in P should be corresponding eigenvector. So this order should follow. So let's say I write 3, 5. Then this column should be 12. Also, the scale doesn't matter. So, so after we got, we use our way, and this P quite different from this, but kind of similar. The reason is, if I pick a different vector from still the same eigenspace, I'm going to get, I can get this. So, for example, from here, let's say I pick -1 for x2, -1 for x2. And I'm going to have 1 and -1, right? So that's going to be here. Okay. Let's say for x2, for the second column of the P, let's say I pick -2 here. Then I'm going to have 1 and -2. That's here. Doesn't matter. Once you find P and D, you can find this general form. That makes sense? Well, let's try it together. When we are reviewing, I'll give you different matrix, and you just try to find D and P. Let's try that maybe today or tomorrow. Anyway, so here. Let's say we have 3 by 3. Quite complicated. What would be the first step? First step. Yes, find the eigenvalues. And then find the corresponding eigenvectors. Right? And then you construct D and P. And that'll be done. That'll be it. That'll be all you need. Okay, first step. How can you find the eigenvalues? What did we find? It's quite complicated. I'll give you. But just tell me the outline how to find the eigenvalues.
Start off with lambda.
Okay. This, right? So what I'm gonna have is okay. I can rewrite this. A minus lambda I. Yes. Okay. What is the purpose of rho reduce? Correct. So what? Okay. We want to find determinant of what matrix? Yes. So we want to find determinant of this matrix. So we cannot rho reduce before this. Yes. Good question. You want to find eigenvalue determinant of this. You set it equal to 0, and it's quite a complicated process. I'll just give you the answer. Let's say you get this. If I ask you 3 by 3 matrix an exam, I'll give it the characteristic matrix. I'll give this. So once you get this, you can find out the eigenvalues, right? 1 and -2. Then you can find. Can you find eigenvectors based on this eigenvalues? Okay. Same thing. Yes. How do you find eigenvalues? Okay, let's say if lambda is 1, what is corresponding eigenvector? Original -1, right? 1 on the main diagonal line. So -1, -1, -1. You get matrix. Right? You want to construct a augmented matrix. The last column is going to be all 0s, right? And then you find the solution, right? And then you find the eigenvectors. Okay. So once you get this, you can find out the eigenvalues. Okay. Then you can find the solution, right? And then you find the solution. Okay. So once you get this, you can find out the eigenvalues. Okay. So once you get this, you can find out the eigenvalues. Okay. Makes sense, man. It seems like no one can have it. Let's go. Okay, so let's try this. I want you to find this. Right, if lambda is 1, what is eigenvector? Find it, guys. Please.
What was the second eigenvalue?
Oh, it's 2. Negative 2. 1 and negative 2. Do you guys think the money you pay for college for FSC is worth it? If for all classes you take here, it's like my class is going to work it.
Yes. I was about to say, depends on the class.
But you have kind of freedom to choose your class, between not full class or good class. You have freedom. You can kind of you can do your best to make your money worth it. Is there anyone who has more than 1 year in FS? More than 1 year to go. Oh, many? Okay, good. Okay, then I can give you just life advice. Okay, when you're trying to make a decision, just for me, just my personal advice. And I don't want to say that I'm better than you guys, because Dave is right there. He is 10 years old. I cannot say anything.
Who's
but-
older, that doesn't make me.
Yeah. So I try to be helpful right next to him. And also Dustin is the same age as me. And then
I think I'm older, right?
were you born 93?
92.
Oh yeah, you were older. I'm not saying you're better than me. I think I'm only better than you. I'm better than you only at that. Other things you're way better than me. I'm sure. English can. Oh yeah, Korean, yeah. So yeah, Korean. I got 2 things here.
Yeah.
So, honestly, I wanna talk about many things other than that. Okay, the one thing that I can tell you that makes your money for college is worth it, 100%, is I think take advantage of the programs that are available here for you. I think one of them is I strongly believe exchange program. So I started. I think Dustin heard it. This is your second time. So I talked about this last semester. So maybe not too late because you're too old. But don't you get money from the government?
Yeah.
Right? So maybe it's good for
College
you.
is free for me.
Yeah. So
I get paid to be here.
Yeah.
Yes, that's good. So the good thing of the exchange program is you pay money here, you go to the other school in the other country, right? But you still get the money for your expense, like the living expense. So I think that is enough for you to cover to leave other country, even if you bring your kid. Yes.
What's the cost of living?
A lot. I mean, either it is same as here. How much rent did you pay here? 544 a month. Yeah, it's about the same. Also, food costs insanely like Americans. I mean, what do you complain? You're living in the most wealthiest country in the world and also strongest country. Your dollar value is a lot stronger than other currency. So if you think that let's say, how much do you pay for lunch or dinner if you want to eat out?
$50.
I mean,
Where are you eating out?
yeah, 50.
I don't eat at McDonald's.
Okay, so let's say you go to Disneyland, let's say just and including tax and
Okay.
Sushi.
yeah, sushi. I mean, sushi is a lot cheaper in Japan.
Yeah.
Better quality.
Yes.
I can't eat sushi. Just have a one bite, just one go.
Yeah.
Wait, really?
Yeah, Jesus. Jesus, no. But
Well,
anyway,
Japan, you're like this close to water. Here, you're a little further away from
Yeah.
fish.
But
So.
the chef here is hard. I can make better sushi in my home. But anyway, so let's say you pay $20 average for lunch, tax, tip included. Asian country you don't pay tax. I mean tax is included. You pay, but also you don't pay tip. Yeah. So $10 gives me a lot of joy and happiness for me to eat out. So if you're worried about the cost you will have to spend in other country, and compared to what you spend here, it's not that different. So basically, you can experience, can stay other country with more diverse experience with the same cost, I believe. And so yes. Since we were talking about this linear algebra, right? Let's talk about eigenvector, vector space. So let's say you have vector, right? One vector. You spend this. Right? What is the dimension you get if you spend only one vector? Only one vector.
One dimension.
Okay, one dimension. If you increase if you get another independent vector, you spend it, what dimension you get?
2.
Okay. So you keep doing this, and then you can increase the dimension of the space, right? Okay, so okay. I think learning language is almost same as obtaining a vector in your life, in the dimension of your life. Okay? Or experiencing other countries is also increasing the dimension of your life. Okay? So now I have Korea. Right? I got another independent vector, English. Spend this 2 dimension, and I also speak Japanese because I studied abroad in Japan. So I got 3 dimensions, right? So nowadays I'm trying to learn Portuguese. So 4 dimensions, right? So once you, so I'm not trying to brag about myself at all, but if you experience the other country or other culture, especially that is not similar to your culture, for example, for you guys, Western people, like America is considered Western culture, right? So if you experience, the more different you experience, I think the richer your life will get, I believe. So for you guys, I recommend exchange program where going, even just traveling to Asian country. Like, for example, Christian can speak Spanish, but sometimes, I speak Japanese, so I tend to go to Japan often because I feel more comfortable. Actually, the bigger challenge you face, I think the bigger you will grow. So, yes. Yes.
What's the biggest difference between Japan and Korea?
Okay, what is the difference between Mexico and Colombia? Kind of similar, right? It's kind of a similar culture, but a little bit different, right? Yeah, kind of like but what is the difference between USA and Canada? Quite hard to say, right? But from your standard, it's all same. But for me, it's so different because you know very details, right? So, for example, I put chopstick like this on the table, right? Dinner table. The Japanese put chopstick like this. It's like minor difference, but for you guys do chopstick the same. Right? But anyway, so
I put my chopsticks in the holder and grab a fork.
Yeah, so anyway, so.
I've heard it's never been a better time to go to Japan because the yen is like 151 yen per dollar or something.
Yes. Okay, let me talk about the Cuban issue, guys. So I'm not trying to be political at all. I'm not talking about the color of your skin or, I don't know, just your nationality, okay? So you're born in the, you open your eye after you're born, see you're around, and then the country you just born with is just America, right? USA. That happened to be the strongest country, greatest country. I don't know about politics, maybe. But just think about it, guys. A lot of people over the world come, they do their best, they risk their life to come to the United States. But you're born here. Speak English from the beginning. For me, okay, when I try to come to the United States as an exchange program, as an exchange student, I had to take so many English tests to pass. Otherwise, I'm not qualified to even apply for this. But you guys don't need to learn any language. I mean, you can go to the other country and still take English class because English class are always available for international students. So you just go to the government office, get passport, just apply for exchange program school. For me, for a non-English speaking student, they have to work so much hard to learn English. Just think about it, you learning Korean, Chinese, or Japanese from the beginning. If you try to learn Spanish, it's kind of similar, right? But learning totally different languages takes like 5 years project, at least like 5 years project, 10 years project to master it, actually be able to speak well, understand well in a college level classroom.
When did you start learning?
I mean, elementary school, right? They force you to learn. Yeah, anyway. So my recommendation is, my life advice for you, not to be.
What's your favorite thing about America?
Oh, the opportunity, land of opportunity. Just go other countries.
What about culturally?
Culturally, I mean, it's quite diverse. If I want to experience like really wide, sorry. If I want to really experience the true authentic. I don't know what. Let's avoid the question.
I think it's great that like literally you could go up and down just one block anywhere in Tallahassee and probably find 5 different cultures and eat 5 different types of meals at somebody's house along that one block. Like you have jambalaya, you could have burgers, you could have some Puerto Rican food. You can find all sorts of different stuff just in one town. And then you've got to realize you've got all these different towns in each state, 50 different states. It's a melting pot really in the U.S. And that's what I like about it because I've gone all over the Mediterranean. I've gone to Asian countries. I've gone to the Gulf. So I've seen all sorts of different stuff. And it's usually all that one sort of thing in that country. So you can go to Romania and everything's Romani. You can go to Scotland and everything's Scottish. You can go to Mexico and everything's Mexican. You can go to Colombia, everything's Colombian.
Right.
Come to Florida, and you have so many different options.
Yes, I totally agree with you. So they're quite diverse.
I remember going to Washington and being surprised that like the amount of like Asian population there was like Latino population here in Florida. It's like such a big different concentration between the 2 states. I mean, it makes sense like geographically, but it's like I never even thought about that.
Yes. So you can experience diversity. Actually, let's say you go to Korean town in Toronto. It's actually quite the biggest Korean town in the States. I mean, you get a tip, one bite of taste. You get a taste of Korean culture, but actually going to Korea is a totally different story. So my life advice is just if you're a third year or if you have more than 1 year to go in FSU, just apply exchange program. Just trust me, and your life will be more rich. You have more richness in your life. I mean, time. I mean, not those who are actually studying abroad right now. Katusha is doing it now, right? But not the US students. Yeah. But anyway, guys. So, because I changed my life. I mean, I came to United States as an exchange program. So I was supposed to be here just one semester. I just decided to have fun. I took 6 sports classes instead of taking just major classes. Right? If you take sports classes, just attend, get straight A's. Right? If you actually be in the classroom, just get A. It's a test. Just attendance is the criteria for your grade, right? So I end up getting straight A's. They give me scholarship. Okay, I'll stay. Yeah. So yeah, that actually just changed my life. That's why I'm here. If I didn't attend, like let's say, I just didn't even try to take the sports classes for the first semester to have fun, I won't be here facing it. So you never know. Actually, putting yourself in a totally different situation will make you grow immensely. I truly believe that. And then, if you apply for an exchange program and go to other country and at least spend there at least one semester, I think you learn more from that than just class, stupid class. Honestly, you can learn this kind of thing on YouTube. Just like open up YouTube, just eigen, type eigen. The MIT professor will teach you better than me. Really. But those experiences are really valuable, and then you cannot exchange that kind of value with any other one. Even if someone comes up to me and like, I will give you $1 trillion, would you go back and not exchange the program? And I'll still pick the same choice. I'll just go to exchange program with no money. I will just steal software, but I will learn a lot. Anyway, okay, guys. Yeah, but last thing. If you want to apply for exchange program, you better get your passport ready and then apply. Start the application process 2 semesters before. So the earliest you can go is spring. So contact CG. They had their Instagram Instagram ID. Because you suddenly think, oh, I want to go exchange program, I want to go abroad, and then you just think, oh, the earliest program that I can go is a year from now, and then you're gonna graduate at that time. It's too late. So I prepared 2 years before I wanted to go. So it takes a lot of process. Anyway. Okay, so how do you do this? Subtract 1. So you get 0, 3, 3, negative 3, negative 6, 3, 3, 3, 0. Okay. And then what can we do? Okay, so after row will reduce, what do you get? Augmented matrix always works. And then what? 1, 1, 0. And just swap this. First and second, third row, and then scale them to 1, and then negative 1, negative 2, negative 1. I'll just erase it. Okay, this is perfect. And then what?
Row 2 minus row 1 minus row 3.
Okay, so 1, 1, 0, 0, 0, 1, 1, 1. And then you're gonna get 1, 1, 0, 0, 0, 5, 1, 1, 0, 0. And then what? But still. So what is the answer? So how many free variables do we have?
1.
Oh, good. They have one more step?
Go by one minus root two.
Oh, minus root 2. Okay. Sure. 1 minus. So I get 0 here. Like this, right? Chris, see? Okay. So what? X1 is x3, x2 is minus x3, x3 is 3. So therefore the vector we're gonna get is 1, -1, x3. This. So this is what? Eigenvector or eigenspace? Space. You pick one thing, then you become the eigenvector, right? So let's say for simplicity, I pick 1 for x3, then just 1, -1, 1. Then this. Okay. So you do this. You repeat this process for different eigenvalue. Let's say -2, right? And then you're gonna have these two eigenbases. These eigenvectors. Why do you have 2?
You have two free variables. in your
2
other
free variables. And then you can get the hint from the multiplicity of the characteristic equation. So here, 1. Multiplicity, 1. Eigenvalue -2, but you have multiplicity 2. You can kind of assume that I may have 2 eigenbases. That's why you could pick 2 different eigenvectors. Okay? Does that make sense? David, does it?
So you're saying you have 2 of those because you have 2 free variables? But
Yes.
I always said we only have 1 free variable.
That was a mistake, I think, because we had to row reduce it fully.
Which one? This one? This one? First one?
Yeah.
The
no.
2 free variables is for a different eigenvalue.
When lambda equals -2.
Oh yeah, this is for lambda equals 1.
Mhm.
Okay? So I just found out a eigenvector that is corresponding to this eigenvalue.
Right.
For a different eigenvalue,
Oh.
I'm gonna have different eigenvectors, also different eigenspace.
Yeah.
Yes, so let's say you do row reduce and you get 2 free variables. Let's say you find these 2 eigenvectors. Okay? And then what? Next step, you construct P that is simply just copy and paste eigenvectors. Okay? The order does matter. So V1, V2, V3. So if I decide to write this in this order, then I'll have to write the eigenvalue matrix. Okay? So I have to write 1 first, then 2, and then 2 here. Okay? That's why you have 1, -2, -2. Yes?
Could you switch around like the -2 to be the first column? But as long as you change where the vectors
Yes,
are,
yes.
it's fine.
Yes, so as long as this order aligns, the order of the eigenvalues or order of this are aligned with the eigenvectors, then the order doesn't work. You can decide.
So columns 2 and 3 can be switched because they're both for
Mhm,
-2.
mhm. Yes.
Okay.
So, I mean, after you construct P and D, the way to verify is this thing. If you matrix A is given, and you just found a P and D, right? You can also find P inverse. You know how to find P inverse, right? Even if it's 3 by 3, if you learn test 1, you copy paste P. You write identity matrix, and you row reduce to get identity matrix here. And the result you get on the right is going to be the inverse, right? But anyway, so you can multiply these 3 and verify if the result is same as this. Okay? But finding the inverse is a lot of process, right? So you can just simply what you can do is A, P, P, D. You multiply P on the both sides, then I can cancel this, right? So even without trying to find the inverse of P, I can verify the result. Okay? So you verify this way, and then the end up the result will end up this way. Okay, I'll call it a day. I'll see you Monday, and then we will review things from the first chapter after the example.
So where did we get to? The truth-based testing? What section are we up to?
Up to 5.2.
Okay.
Up to 5.2. No, I won't. No, I like. Yes, your computer science major, right?